Hello everyone, welcome to the course structure analysis. I am Dr.S.Pachaiappan, Assistant Professor, Department of Civil Engineering, Aditya University. So today we are at the 31st lecture. We are discussing about the analysis of 3-hinged hatches. Last lecture we have seen how to calculate the horizontal thrust and then bending moment across any section for a 3-hinged hatch subjected to UDL throughout the span. In today's lecture, we are going to discuss about the analysis of 3-hinged hatch subjected to UDL at part of the arch only. So, at the end of the lecture, student can able to analyze a 3-hinged hatch subjected to a uniformly distributed load on one half of the span. So, here we can able to see the configuration. The 3-hinged hatch subjected to 40 kilonewton per meter only the left portion of the 3-hinged hatch. The right portion is not subjected to any loading. Now, first we need to calculate the reaction force. We cannot able to take the reaction force is 40 multiplied by the span and then divided by 2 because this is unsymmetrically loaded 3-hinged hatch. So, we need to take the moment at the support B. So, I am going to taking moment at B equal to 0. So, the vertical force VA multiplied by the horizontal distance is 20. Okay. Then the force W is acting downward direction. The force is 40 kilonewton meter. 40 kilonewton per meter. So, minus of 40 multiplied by, it is acting at a distance of 10, okay, multiplied by where the UDL will act at center, therefore 10 by 2 plus this 10 meters also we need to account. Why? Because we are taking moment at the point B. So, plus 10 equal to 0. So, then if you solve for this, we will be getting the VA is equal to 300 kilonewton. So, we will solve for this, we will be getting VA is equal to 300 kilonewton. Now, what about VB? VB can be calculated by using total load concept. So, total load is equal to 40 multiplied by 20 is a total load minus of 300. We can write like this, total load is equal to VA plus VB. The total load is 40 multiplied by 20. So, 40 is the intensity of the load. Actually, this load is acting only at 10 meter distance, only part of the span having the UDL. So, we cannot consider 20. So, the total load is 40 multiplied by 10. Okay, 40 multiplied by 10 is a total load, and then VA we calculated 300 kilonewton and plus VB we don't know. So, VB is equal to, so total load is 400 kilonewton minus 300 kilonewton. 400 minus 300 will be having VB is equal to 100 kilonewton. VB is equal to 100 kilonewton. So, from this we got the VB is 100 kilonewton. Now, let us mark these reaction forces in the diagram and then we will calculate the horizontal thrust. So, we got the VA value is 300 kilonewton. We got the VA value is equal to 300 kilonewton and VB is equal to 100 kilonewton. Now, we are going to calculate the horizontal thrust by taking moment at C is equal to 0. Here the moment is 0. The reason is in 3-hinged arches, generally the arches are located support A, support B and then support C. So in these three locations, the moment value is 0. So I am going to take VA multiplied by the horizontal distance, which is 300 multiplied by the horizontal distance is 10, and then minus capital H multiplied by the perpendicular distance is 8. The reason I am taking minus H is, let's draw the free body diagram here. The horizontal force H is acting here, and then the perpendicular distance is nothing but the height of the arch. So force multiplied by horizontal distance is moment, and it is rotating in a anti-clockwise direction. So for anti-clockwise direction, we supposed to consider negative, and then clockwise direction we consider the positive. That's why we have the minus of H multiplied by 8. And we need to consider the downward forces also, which is W, which is acting in a downward direction. That's why we have a minus sign. And the intensity of the loading is 40, and it is acting at the distance of 10 meters. Then for UDL, where it is acting, we need to consider its center. That's why 10 by 2 equal to 0. So simplifying upon this, I will be getting 8H equal to minus of 1000. So here the minus will be get cancelled. We'll be having 8H equal to 1000. So H is equal to 1000 divided by 8. We'll be getting H is equal to, by simplifying upon this, we'll be getting H is equal to 125 kilonewton. So this is the horizontal thrust of this arch subjected to UDL and the portion of the beam only. So in this way we can able to calculate the horizontal thrust of the 3-hinged arch very easily. This is about the lecture today. So at the end of the lecture, we learned how to calculate the horizontal thrust of a 3-hinged arch subjected to UDL only the part of the arch or half of the span. So thank you for watching this lecture. Thank you.